So what's responsible for the extreme weather that caused more than 2 months' worth of rain to bucket down over the Western Cape, leaving communities cut off and devastated? Climate scientist and UCT Climate System Analysis Group Research Officer, Dr. Peter Johnston, joins us now. Good evening and welcome to the program, Dr. Johnston. Your insights in the Daily Maverick were really educational. We wanted to share those perspectives with our viewers. What is the first thing climate scientists like yourself think about before and during such extreme weather?
Well, obviously extreme weather is of great interest to us, but we do obviously understand how important it is to the community at large, and especially agriculture and transport, which are the two sort of sectors that are most affected by this extreme weather. First of all, I suppose we look at it and try and analyze what might happen. And it's not our job to issue warnings, but certainly the National Weather Service would issue warnings around that, and we would offer guidance as to what might happen and what the situation is looking like. Then during such an event, we focused on measurements and observations. And then after the event, I guess we look at analysis and try and see how that fits into the big picture, whether it's a major record, whether it's establishing any sort of trend, and try and determine what the likelihood of something like that happening again.
Very, very interesting, and I guess it's also really heartening for us to hear that there is a sense of, the scientific community working together when things like this happen to share information and best practice. So we hear about a cut-off low-pressure system at high altitudes, an atmospheric orphan, and how it intensifies, leading to the apocalyptic-style weather we saw batter many areas. But can you explain what led to this in simple terms?
Yeah, that's very difficult to explain in simple terms, but essentially what we have is a westward to eastward wave motion where cold fronts originate and these mid-latitude cyclones originate. So if you think of the wave flowing around the South Pole, the peak of the wave, or the crest of the wave, is what carries the cold front towards southern Africa. And these waves vary in the amplitude and the wavelength, so they can become quite, they can stretch quite far inland, if you like, with high amplitude. In summer, obviously, they move further south, but it's in winter that they move north and they affect the Western Cape. Now, occasionally, one of these waves, it's almost like a wave in the sea that breaks off and breaks, like a surfing wave, and the top of the wave then spins off and is isolated and becomes what we call this atmospheric orphan that we've been mentioning. And that becomes a cut-off low. It's cut off from the flow from west to east, and it becomes almost stationary. And we saw this developing on Friday, and all the warnings did go out on Friday and Saturday, warning that this cut-off low was very intense. In other words, it stretched from the surface to way up into the atmosphere, almost 8 kilometers up into the atmosphere, and it stretches out with this convective nature. So it's pulling moist air upwards into the sky, which is then rapidly cooling, forming clouds and rainfall. Yeah. And so we can see the system develop, and then it gets stronger and stronger as it draws more and more moisture into it. But it's very unpredictable at this stage, and one can't say exactly where it's going to go, but the model's got it pretty much right.
What you're describing sounds almost anomalous or freakish. Is it, or is it something that does?
It is quite freakish, although we have cut-off lows every year. Most of them occur out at the sea, and they don't even get mentioned. They're not noticed. Occasionally, one like this causes a lot of damage. We had one earlier this year that wasn't quite as bad. We had one in 2017, which was very bad. And then we obviously had the things like the Lanesburg flood, which was the same phenomenon, but just rained a lot in one spot. And that spot happened to be the drainage basin for the Buffalo River, which then all congregated and the water flowed down and washed away Lanesburg. So it's not a normal phenomenon, but it's not abnormal. These happen from time to time. They happen in other parts of the world as well. It's not just affecting us. But wherever this intense low sort of drops off or becomes cut off from the westerly to easterly flow, we get these cut-off lows developing. And they are renowned for very heavy and unpredictable rainfall. So that's one of the common characteristics. But they don't always develop as deeply as this one did. Some of them can be quite shallow, some of them can be limited just to the upper atmosphere, and in which case on the surface you don't even notice anything, there's just a bunch of cloud. But when it's very deep like this one, and is associated with very heavy rainfall, it is unique, and it is not common. We must be quite honest, this sort of thing doesn't happen every year.
Did it set any kind of record?
It certainly has set a lot of records, and we're still busy collecting those. For example, in most places in Cape Town, there was a record amount of rain on Sunday. We've never seen that amount of rain before. Some places at 126 millimeters, places in the mountains had over 200 millimeters in one day, and that is unheard of. So the phrase two months of winter rainfall, generally speaking, in South Africa, in Cape Town or the Western Cape, in an average winter month, depending on when you are, we have around about 90 to 100 millimeters. That would be June, July, and August in each of those months. So combining those 2 months, any of those 2 months gives you about 200 millimeters, and certainly in many places we had over 200 millimeters in these 3 days. And really it was mostly 2 days of rainfall.
Yeah.
It was Sunday and Monday.
And you could see the devastation, it happened so rapidly, people suddenly in a flooding situation, quite rapidly. Just a quick one before we let you go. You talked about the data, the modeling, the information sharing and so on. And yet again, you also say that it's unpredictable. So can we create can we predict when this can happen with this intensity again and warn people in advance?
Well, certainly the advance warning, though, is limited to 2 to 3 days that we see it, because if we identify it in the Atlantic Ocean a week ahead of time, there's very little chance that it's going to persist and strike the Western Cape in a particular area. It's very unpredictable in that way. So 2 or 3 days beforehand, we can look at the models and say, right, has this happened before? What's it likely to do? Where's it likely to go? And then create more certainty as we get closer to the time. And because the rainfall is so heavy, and water rushes down, it's quite hard to be prepared. But preparations should be in place. Every winter we should be clearing the rivers, we should be clearing the drains, we should be very, very aware that heavy rainfall could happen at any time in winter.
So, and literally 20 seconds, when you match what happened, the extent of the destruction with the province's response systems, would you say that some of those preparations were in place?
No, very definitely. They very definitely were in place. Many of them. I think it was just more rainfall than anyone had ever expected, and that was the case. There are cases of bridges that did withstand the downfall, and there are other bridges that didn't. And what we have to do from now on is try and learn how to prevent these things from being damaged again.
Thank you so much for your time. We really appreciate it. Climate scientist and UCT Climate System Analysis Group Research Officer, Dr. Peter Johnston.